Now let's see how to use it in the Excel. So first of all, you have to download the Voltage default Excel from the module 6 practice. And then you will create a pivot table for A1 to H301. And then in the pivot table field area, drag the marital status field to the row area, drag the default voltage field to the columns area, and drag the customer number field to the values area. And click on the sum of the customer number in the values area and select value field settings. When the value field settings pop out, under summarize value field, to select count. Then we need to set the number format. So click on the count on customer number in the value area and select the value field settings when the value field settings dialog box appears. And click show data as. Change the probability to % of grand total, then click number, and change number format to 2 decimal, then click OK. So now we can see that we have the marginal probabilities and the joint probabilities. And if you want to show the probability of the joint, for example, if you want to show the probability of the single and default voltage, which is the PS intersection D, you can find the cell you want to represent this probability and just need to type equal and click cell 6. And here you can see for the D6, for the D9, I used a formula called formula text. So this is the one, it doesn't have any functionality for our probability. It is just a function to show the formula for a specific cell we're looking for. Like here, I'm using the formula text bracket C9 is because I want to show the formula in D9. I want to show the formula of C9 in D9. So I will use a lot of this to show you what is the formula looks like for a specific cell. Is that in this example, I won't have a functionality formula in the C9, but since I have the result automatically in C9, so I don't know what exactly the function or the formula I used in C9. So in this case, I can use the formula test to show what is the formula looks like in C9. So here, since we click C6 in a C9, so it's supposed to show the equals to C6, right? But it didn't show C6 as we expect because the value of the C6 is not the original value. It is the status result calculated by Excel function. So the content explains what does the value of the C6 means, which is the probability of the person who is single and default on voltage. So you can tell that the function here says the get pivot data. So it shows the probability of the marital status, which is single, and the default on voltage, which is yes. And so here, the probability of S intersection D is 0.14, which is the value in C6. We can also do it in the Tableau. So in the Tableau, create a new data source using the voltage default table. If you forgot how to do it, check the module 5 practice. And then in the new Tableau sheet, use voltage and marital status to create a cross tabulation, which you have done it in module 5. So to do so, you have to drag the voltage and marital status into the columns and rows, and then drag voltage default count into marks and change the details to labels. And then under Analytics, drag the tables to cross tabulation to generate a total calculation of both columns and rows. And then you have to change the counting to probability by right-click CNT voltage default, which is the count of the voltage default. Click Edit Table Calculation. Choose percent of the total as the calculation type, and then choose table as the compute using. So now you have exactly the same cross tabulation, which is the merging probability and the joint probability we have in Excel. To get the conditional probability in Excel, we just need to right-click on any numeric value in the body of the pivot table and select Show Value As, and choosing percentage of row total to give us the conditional probability given by the marital status. So here you can see that the grand total for marriage and then the single are both 100%, to show that whatever percentage showing in the joint probability, they are the probability given by either married or the single. So in this case, the C6 is not P intersection PS intersection D anymore. It should be P D given by S, because in this case, the single is 100%, so that the single is the condition, and default voltage is the probability. So here is probability of the D default voltage given by the single. And then if we want to do the same thing for default voltage, we just need to change the percentage from row total to percentage of column total. So in that case, we will have 100% on both no and yes for default on the voltage, and then every joint probability are the probability given by either not default or default. And then in this case, the C6 is not P D given by S, it should be PS given by D. It's because the default voltage is 100%, and then we just find someone who's a single given by the people who are default on the voltage. And the same thing in the tableau. We can change the compute using from table to table across. So in this case, you can see that the grand total of the married or the single are both 100%. In this case, the condition is married or the single. And then if we want to see that if we want to change to given by default voltage, we just need to change to table done. For question 2, suppose Grill Aircraft Engines sells aircraft engines to commercial airlines. Grill is offering a new performance-based sales contract in which Grill will guarantee that its engines will provide a certain amount of the lifetime flight hours, subject to the airline's purchases a preventive maintenance service plan that is also provided by the Grill. Grill believes that this performance-based contract will lead to additional sales as well as additional income from providing the associated preventive maintenance and servicing. From extensive flight testing and computer simulations, Grill's engineering group has estimated that if their engine received proper parts replacement and preventively maintenance, the mean lifetime flight hours achieved is normally distributed with a mean 36,500 hours and a standard deviation with 5,000 hours. Grill would like to know the percentage of its aircraft engines will be expected to last more than 40,000 hours. In other words, what is the probability that the aircraft lifetime flight hours X will exceed 40,000? This question can be answered by finding the area of the darkly shaped region in this figure. The Excel function norm.dist can be used to compute the area under the curve for normal probability distribution. This function has 4 input values. The first is the value of the interest corresponding to the probability you want to calculate. The second is the mean of the normal distribution. The third is the standard deviation. and the fourth is true or false. We'll enter true for the fourth input if we want the cumulative distribution function, and false if we want the probability density function. In cell B5, we use the formula norm.dist 40,000, B1, B2, and true. B1 contains the mean of the normal distribution, and B2 contains the standard deviation. Because we want to know the area under the curve, we want the cumulative distribution function, so we use true as the fourth input value in the formula. The formula provided the value of 0.7580 in cell B5, but note that this corresponds to the probability of the x less than or equal to 40,000. In other words, this gives us the area under the curve to the left of the x equals to 40,000. And we are interested in the area under the curve to the right. To find this value, we simply use 1 minus 0.3580, which is 0.2420, that is in cell B6. Thus, 24%, like 0.2420 is the probability that the x will exist 40,000 hours. We can conclude that about 24.2% of the aircraft engines will exist 40,000 lifetime flight hours. And then suppose Gear offers a discount guarantee if an engine fails to meet the lifetime flight hour target. How many flight hours should Gear guarantee to that so that no more than 10% of the engine qualify for this discount? So this scenario can be visualized graphically in the figures. The area under the curve to the left of unknown guarantee on lifetime flight hours must be 0.1. So to find the appropriate value using Excel, we can use function normal.inv. The inv function has three input values. The first is the probability of the interest, the second is the mean, and then the third is the standard deviation. So in cell B8, we can use this function where the mean and standard deviation provided. This provides a value of 30,000 and 92.24. Thus, a guarantee of 30,092 hours will meet the requirement of approximately 10% of aircraft engines will be eligible for the guarantee. This information could be used by Gear's analytics team to suggest a lifetime flight hours guarantee of around 3,000 hours. Perhaps Gear is also interested in knowing the probability that an engine will have a lifetime of flight hours greater than 3,000 hours but less than 40,000 hours. How do we calculate this probability? So first, we can restate the question as follows. So what is the probability of 3,000 hours less or equals to x and then less or equals to 40,000? So this figure shows the area under the curve needed to answer this question. The area that corresponds to the probability can be found by subscribing the area corresponding to the probability of the x less or equals to 3,000 from the area corresponding to the probability of x less or equals to 40,000. So we've already calculated the probability of the x less or equals to 40,000 in B5. And then we can calculate the probability of the less or equals to 30,000 in B10. Which is 0.0968. And then we can use the B5 minus B10 to calculate the probability of 30,000 less or equals to x less or equals to 40,000, which is 0.6612. So in that case, we can tell that there are approximately 66% of the probability that the lifetime hours would be more than 30,000 and then less than 40,000.